steel reinforcement. Steel reinforcement. Now we will provide the steel reinforcement. So, so we know that the moment in x direction and y direction are same. Okay. So I will write here as moment in x direction and y direction and y direction are same are same. Steel reinforcement steel reinforcement is not same due to due to is not same due to change in effective depth in y direction. Okay. Now, so that now we will calculate steel in x direction first. So what is the steel in x direction? So we called it as ASTX. ASTX. Steel in x direction. So the steel in x direction ASTX. What is the formula? 0.5 FCK BD divided by FY in bracket 1 minus under root 1 minus 4.6 mu upon FCK BD square. This is the formula. Now put the values. ASTX is equal to 0.5 into FCK. What is the value of FCK? It is 20 into B. B is 2750 into what is depth? What is our effective depth? We have calculated for the foundation. It is at I think 462 in x direction divided by it is divided by 415 in bracket 1 minus under root 1 minus 4.6 into what was our bending moment? It is 518 point something. 518 into 10 to the power 6 whole divided by FCK BD square 20 into 2750 into D square 462 square. Okay. The bracket is complete over here. Now solve this, so we will get the value of ASTX, steel in x direction. So it is, what is the answer? It works out to be 3283 mm square. Okay, this is the answer. So now calculate the number of bars. Calculate the number of bars. So here you can write assume 16 mm bar diameter. Okay, 16 mm dia bars. What we will get number of bars is equal to total area of steel, that is 3283 3283 divided by area of single bar. So area of single bar is pi by 4 into 16 square. So let me know how many number of bars. It is 16.32, which is nearly equal to 17 numbers. 17 number of bars. Okay. So ASTX provided. How, what we are going to provide, that we will calculate. Provided how many number of bars? 17 number of bars. What is the diameter of each bar? 16 mm is the diameter of each bar. So calculate the ASTX provided. What we are providing. It works out to be 3418.05 mm square. This much of area we are providing. So now calculate the spacing. So for the footing spacing, it is calculated by our regular formula. So area of single bar, pi by 4 into 16 square. This is the area of single bar divided by total area. AST provided 3418.05 multiplied by width. So our width is 2750. So here we have not assumed initially that we are doing the analysis per meter width. That assumption we have not done here in the footing. That is why we are taking overall all width. It is 161.76. 161.76 mm, which is nearly equal to 160 mm center to center. Okay. So you can also calculate in this way that, see, how many number of bars are there? 17 number of bars. Okay. How many number of bars required? 17 number of bars required. Okay. So these bars, this is the steel along x direction. Okay. So this steel is parallel to x direction. So the spacing will be calculated along y direction. So the width of your y direction is 2750. So then if you do 2750 divided by 17, then also you will get the same answer, 161.76. Okay. So now I will write over here provide. So ultimately I will write provide 17 numbers of or 16 mm diameter bars about 160 mm center to center. Okay, this is along x direction because we have calculated steel in x direction. So along means parallel to x direction. So after that, same way we will calculate steel in y direction. Same way we will calculate steel in y direction. So ASTY, steel in y direction is ASTY, which is equal to, again the same formula, zero point 0.5 FCK BD divided by Fy in bracket 1 minus under root 1 minus 4.6 mu divided by FCK BD square. Okay. Now here there is a change. There is a change in the effective depth. Now how that depth changes? See over here. So this is column line. If I draw the sectional elevation, here footing is provided like this. So now what is happening now? See, in the x direction you have provided how many bars? 17 bars. What is the diameter of the bar? 16 bar diameter. So now here in the x direction already a bar is there of 16 Already a bar is there. Here in the x direction already a bar is there. So this is the bar. Okay, 16 So now whatever steel you are going to provide in the y direction, whatever steel you are going to provide in the y direction, that steel will be above this. Okay, so here it is the y direction steel in this way. This is the steel in y direction. So I can say over here this is the steel in y direction. Yet we have not find out the quantity. Okay, but and this is the steel in x direction. Steel in x direction. म्हणजे थोडक्यात मला काय सांगायचंय? First we will lay down the steel in x direction, and above the x direction steel we will lay down the steel in y direction. If I show you in the plan, now this is the plan. Okay, so this direction is your x direction and this vertical direction is your y direction. So whatever the steel is there in x direction, that all steel will be parallel over here. This is your steel parallel to x direction, means along x direction. And though this steel we have calculated 17 number of bars of 16 diameter, about 160 center to center. Now above this steel, after laying down this steel in x direction, we will then lay down the steel in y direction. Okay. Then we put the steel in y direction. So our x direction steel bars are below the y direction steel bars. Or in the other way you can say that your y direction steel is above the x direction steel. Okay. So now if you observe here closely, what I want to point out over here. So see, this is your clear cover, this much of distance. So I will draw the lines first so that it is easy for you to understand. I will project some lines over here and then I will tell you. Okay, okay. Now see over here. So this is your clear cover. This much of distance, whatever may be the distance is there, this distance. This is what? This is your clear cover. Okay, this is your clear cover. And normally in the case of footing, clear cover is 50 Okay. Now this is the bar in x direction. हा जो काय मध्ये आहे. What is this? This is the bar in x direction. आणि हा बार किती आहे? This is the bar in x direction. So 16 So x direction bar is there. Okay. आणि मग तुमची इफेक्टिव्ह डेप्थ म्हणजे काय होणार आहे y डायरेक्शन ची? From this footing up here to up to this point. This is nothing but your effective depth. This is nothing but your effective depth small d in y direction. Okay, this is your effective depth in y direction. Now let us see the values. So now this clear cover is 50 Okay, this bar which is in x direction, its diameter is 16 and above that these bars are coming. So again we will assume 16 bar diameter for y direction also. Okay, we have initially assumed 16 bar diameter for x direction. Same diameter we will take for y direction. Okay. So what is our effective depth now in this case? So for that, this is our overall depth. This is our overall depth. So what is the value of our overall depth? What is the value of our overall depth? How much it is? 520 mm. Okay, so our overall depth is 520 mm. So now how we will calculate the depth d in y direction? Depth, so that depth is nothing but that sorry, here from top up to this point. I have shown the arrow wrongly. So here this is your depth in y direction, d in y direction. So how to calculate this now? So depth, effective depth in y direction, it is equal to your overall depth 520 minus this total is 520. This total is 520 minus we will minus this clear cover. Okay, first we will minus clear cover. So what is our clear cover? It is 50 mm. So the clear cover is 50 mm minus. Now after minusing we will come to this level. So again we need to minus this bar also. Okay, so this bar is of 16 mm. So again minus 16 minus. Now after minusing this bar which is in red color, we will come to the steel in y direction. Then we have to take half of this bar diameter, because from the center of this bar up to top, that is our depth, effective depth. So this much is your effective depth. So up to the center. So for the center it is again minus 16 by 2. If we assume the bar diameter of 16 mm in y direction also. So here we can write assume 16 mm bar diameter in y direction. Okay. So depth in y direction, how much it is now? Effective depth in y direction, that is 520 minus 50 minus 16 minus 16 by 2. So it is 446 mm. It is 446 mm. Okay. So why the change is there? Because this is your steel in x direction. Okay. And above that steel your y direction steel is there. Y direction. So you need to minus one extra bar which is in x direction, which is coming below the steel of y direction. Okay, that we have done over here. So now after this calculate the AST in y direction, area of steel in y direction. AST in y direction is equal to 0.5 into 20 into 2750. Now your depth is 446. Due to this change in the effective depth, your steel is not same, although your bending moments are same. Divided by Fy is 415 in bracket 1 minus under root 1 minus 4.6 mu divided by FCK BD square. FCK is 20, B is again 2750 into 446 square. Okay. Now if you solve this, you will get the value of steel in y direction, which is equal to. Solve now. Good. So I think this answer is works out to be 3415.83 mm square. Please check the answers. Now calculate the number of bars. Number of bars is equal to how many number of bars? So what steel is there? 3415.83. 3415.83 whole divided by pi by 4 into 16 square. So this will give you the number of bars. So again the number of bars are 16.98, which is nearly equal to 17 numbers. Okay. So again the AST provided will be same as that of AST X provided, 3418.05, 17 number of bars. Okay. So AST Y provided is equal to 17 into 5 by 4 into 16 square, which we have already calculated this. This is 3418.05 mm square. After this, we will draw the reinforcement details. So the next point is reinforcement details. We will draw the drawing. Okay. So for the reinforcement details now, first we will draw the plan, and then we will draw the sectional elevation. So plan, if I draw here the footing, so this is the footing. Okay. This is 2750 mm. This is also 2750 mm. Okay. So first, bars which are parallel to x direction, we will draw those bars which are parallel to x direction. So those bars are, we will left the clear cover from the both the sides, 50 mm gap. Okay. These are the bars about 160 mm center to center. This is the steel in x direction. Okay. Now we will draw the steel in y direction also. So in y direction, these are the bars which are in y direction. Okay. These are the bars. I am tentatively drawing. Spacing is not exactly maintaining in the drawing, but on site it should be maintained. So here you can write the name again. So these are the steel in y direction bars, and these are again 17 numbers of 16 mm diameter, about 160 mm center to center. Now we will draw the, what we can say, sectional elevation. If you take the section, okay, if you take the section line from here and you look from this side, and you take the section line over somewhere here, then how does it look? I will draw that first footing. This is the overall depth of the footing. Then from here somewhere column will be there. This is the column. This type of footing is there. Now steel in x direction. So we will draw first the steel in x direction. So this is the steel in x direction. Okay. The steel in x, and it is same. this name. This is the steel in X direction. Now steel in Y direction. For the steel in Y direction, these are the bars. You can see the diameter of these bars over here. This is the steel in Y direction, and you know that these are also 16 bars of 160 center to center. And drawell bars, we can show the drawell bars are the bars which comes from the column. This is the steel from column. These are the column bars which this will comes like this. Okay. So these are the bars from column. त्याचा फुटिंगच्या एन्फोर्समेंटशी काही संबंध नाही. फुटिंग मध्ये आपण डिझाईन करत नाहीत हे बार्स फ्रॉम कॉलम. ओके, सो दिस इज युअर y direction steel in y direction, and this is your steel in x direction. Steel in x direction. I hope now everything is clear to you. Okay, here you can show your overall depth. This is your overall depth, and this depth is 520 mm. These are the dimensions. So you can write over here, these are the dimensions. Detail which is given over here. So now I have told you the reinforcement details, how the reinforcement is placed. These are the bars. You can check out the photos on the internet by yourself also. This is the assignment to you. Okay. Check the photos in the Google how the reinforcement is provided. For different types of footing, different types of reinforcement is provided. So, and what is the big part in this reinforcement? There is nothing, very simple reinforcement is there. This is your footing. Once again, I will tell you, this is your footing. This is your x direction. Okay, and this is your y direction. You have calculated the bending moment in x direction and bending moment in y direction. So both the bending moments are same. 518 kilonewton per meter square. 518 point something will be there. Okay, 518. This is your bending moment in both the directions. After that, you have calculated the steel in both the directions. What was the steel in both directions? It is 16 bars. Okay, about 160 center to center. Here also you have calculated 16 bars about 160 center to center. Now what we have done, this is x and this is y. So always what we have to do now, I will show it with the help of single bar only. See, initially your footing is like this. What you have done, you have provided a 16 bar diameter about 160 center to center in x direction. Okay, म्हणजे हा बार तुमचा कितीचा झाला? This is your 16 bar diameter. This is your 16 bar diameter about 160 center to center. हा कुठल्या डायरेक्शन ला झाला? This is in x direction. This bar is in x direction. Now whatever bar you are providing in y direction, whichever may be the bar diameter and bar, that bar will come above this bar. This is your bar in y direction. Okay, so this is your bar in y direction. This is your y direction. Okay, so now the same diagram. So if you see the same diagram in here in section. Okay, now if I draw the same diagram in section, now see, this is your footing, and above this, here your column will be there somewhere. Here it is your column. Okay, now I have drawn the elevation. So here also, now I will use the same color code so that you can understand. So here, what is your overall depth? Here your overall depth is 520 mm. This is 520 mm. Now what will happen? We will provide first what we will provide. We will provide the bar in X direction. Okay. So by lifting some clear cover from the bottom and side, we provide this bar over here. This is the same bar. This is the same bar which is provided in X direction. Okay. So now, but I will tell you again. So I was explaining you sectional elevation. I think you have understood the plan. Now sectional elevation in this here. This is your depth of the footing. So these are the columns. Because in the column asnarever. This is the column. Okay. So this is your column, and this is footing. Footing. Now what was your depth? This is your depth, overall depth, and this depth is 520 mm. Now by lifting some clear cover, okay, on both the bottom and on left and right side, we have provided one bar over here, this bar, and this is your steel in X direction. This is what, this is your steel in X direction. This is the X direction steel. And what was it? This is 16 mm bar above 160 mm center to center X direction. Now on the Y direction, if I tell you on the similar lines, in the Y direction, so those bar will look, we can see the diameter of this bar. So those bar will come above this over here. Okay, these are the bars in Y direction, above the X bar. Very simple. Okay, in a single bar I will show you. So this is the bar. This is the bar in Y direction. Okay, so here I will write this is Y direction. But again this is same 16 mm bar diameter we have used about 160 mm center to center. Okay. Now the question is of effective depth. Okay. Now when I go with X direction, what will be my effective depth? See, when I see the X direction, what will be the effective depth? So it is up to this level, up to the center of this bar, up to the center of this bar. I will draw it properly. Okay. Here. This is my effective depth from top in X direction. This is effective depth D in X direction. Effective depth. Okay. But when I talk with about Y direction, then my effective depth changes, and that will be up to this point. Okay, up to this point. So this is the effective depth in Y direction. This is the effective depth in Y direction. And why this is? Because after placing the bar on parallel to the X, we are placing the bar parallel to the Y. This is in elevation. Actually already in the previous uh, what we can say 5 minutes before, I have drawn that plan. In plan I have told you, first we will lay down the bars in X direction, above that we will lay down the bars in Y direction. So that is why there is difference in the effective depth in X direction and effective depth in Y direction. Okay, and the points over here are, see, this is your clear cover, whatever may be the distance. This is 50 mm. Okay, this is 50 mm. This is your clear cover. So in this way, we know that this is our overall depth D, If we want depth in x direction, then dx, what is the answer? It is 520 minus your clear cover is 50 minus half of bar diameter 16 by 2. Okay, you will get the value. Then dy, when we talk about dy, then it will be in this case 520 is your overall depth minus 50 mm is your clear cover. Again this bar in x direction, we should subtract that bar also, so that is 16, and then center of the bar in y direction, so minus 16 by 2. So in this way, you will get the effective depth in X, and it is very simple reinforcement. On the both side, you have provided 16 mm diameter bars. First, you are going to lay down the bars in X direction, and then you are going to lay down the bars in Y direction. Okay. So this is your reinforcement details. So now your assignment is you see the reinforcement which is provided for isolated square footing. Search it on the Google and try to interlink that provided reinforcement with this reinforcement which we have provided over here. Okay, so now this is a problem of square footing. Now we will move to the problem of rectangular footing. So these two types of problems will be there for your examination. Out of these two varieties, only a single problem will be asked to you, and whatever problem we have taken now right now, only those types of problems will be asked in the examination. There is no variety of the problem in this chapter. Okay, or in whole DCS there is no variety, simply you are designing everything. So now we will take the next problem. The numerical is rectangular column, rectangular column 400 mm by 600 mm carries carries a load of 2500 kilonewton, full stop. The safe bearing capacity of soil is 150 kilonewton per meter square, full stop. Using M20 concrete and Fe 415 steel, design design rectangular footing rectangular footing design rectangular footing to the column support the column. Draw the reinforcement. Draw the reinforcement details. Even though this sentence is not written in the examination, draw the reinforcement details. It is expected that whatever you design, you should draw the reinforcement sketch of this. Okay, so this is the given problem. The rectangular column 400 by 600 mm carries a load of 2500 kilonewton. The safe bearing capacity of the soil is 2000. Safe bearing capacity of the soil is 150 kilonewton per meter square. Using M20 grade concrete and Fe415 steel, design rectangular footing to support the column. Okay. So load, it is not 2500, it is 2100. The load is not 2500, it is 2100 kilometers. Make that correction. So now we will follow our step, and where the change is there, I will tell you what to change in the rectangular thing. So what is the ratio of the sides of the column? In that ratio we can provide the footing. Okay, this can be also provided to maintain the CG. So what is the load on column? First we will calculate, write down over here, size of column. Size of column is 400 mm by 600 mm. Okay. Then I will not write down the given data again, as it is given in the problem in very simple language. So here I will write down load on column. Load on column. What is the load? It is 2100 kilonewton. This is the load. Okay. Then we will assume 10% self weight of the footing. Okay. So weight of footing we will calculate. Weight of footing. Weight of footing, which is 10% of column we are taking. So weight of footing is how much? 10% of this, it is 210 kilonewton. Okay, here you can write, assume 10% of column load. Assume 10% of column load. Okay. So after this we can calculate the total load. Total load is equal to, what is the total load now? 2100 plus 210. How much it is? 2310. 2310 kilonewton. After this we will find out area of footing. You can refer the steps of the previous numerical. Area of footing is total load divided by safe bearing capacity, which is equal to, what is the total load? 2310 divided by 150 safe bearing capacity. So how much it is? 15.4 meters square. It is 15.4 meters square. So now we need to provide the size of the footing. Okay. So column is 400 mm by 600 mm. So we will assume one of the side of the footing in such a way that ratio, if we considered over here, how much it is? It is 400 by 600. Or either way you can assume anything. 0.66. So we will assume one side, and that one side we will assume as per our convenience. There is, see, I will draw over here. Now this will be our footing, and inside that footing here the column will be there. So for column, this side is 400 mm, this side is 600 mm. Now we got area of footing. Okay, area of footing, how much? It is 15.4 meters square. Okay. So assume one side, so which direction side? X direction side, one side that is horizontal of footing. Let us say I will assume it as a 3.8 meter. 3.8 meter. Then what will be the other side? If I assume one side as 3.8 meter, then 15.4 divided by 3.8. It is 4.05 meter is the other side. Okay. So if I assume this as a 3.8 meter, then this side will automatically become 4.05 meter because our total area of footing is 15.4. Okay, our total area of footing is 15.4. We will adopt that. Okay, so we will adopt this and now provide. So I will write here provide size of footing, size of footing 3.8 meter by 4.05 meter. Okay, so in mm, if you see, this is 3800 mm by 4050 mm. This is our size of footing we have finalized. Now next is the soil pressure. Soil pressure or soil pressure intensity. We called it as a soil pressure intensity. So it can be calculated as sigma is equal to, what is the formula? Load on column. Okay. The formula is load on column divided by area of footing. Okay. So that we can calculate over here. Load on column divided by area of footing. So which is equal to load on column. What is the load on column? Load on column is 2100 divided by area of footing. How much area of footing is there now? Now our footing is 3800 by, so now it is kilonewton per meter square now. So it is 3.8 by 4.05. So you will get the answer over here. It is 136.45 kilonewton per meter square. This is the pressure intensity. And here you can write ultimate or factored factored pressure, soil pressure intensity is equal to 1.5 into 136.45. What is the answer? 204.67 kilonewton per meter square. Depth of the footing. Now we will calculate the depth. Now we will do depth calculation, but first we will calculate the depth from two-way shear consideration. Okay, that is the punching shear consideration. So I will give right over here depth from two-way. This is the first thing. Depth from two-way in bracket punching shear consideration. Okay. For that, you know that the critical section is at a distance of d by 2. critical section is at a distance of d by 2 from from face of column, face of column. Okay. So now we will draw. This is our footing. It is a rectangular footing. Now inside the footing, column is there. So this is the column. Okay. This is the column. And now critical section is at a distance of d by 2. Critical section, I will calculate. Critical section is at a distance of d by 2. So on d by 2, I will draw one more rectangular section. It is like this for the critical section. So here, this distance, this all is d by 2. These all distances are d by 2. I have already explained you in the last lecture. D by 2, this is also d by 2, d by 2, and this is also d by 2. Okay. And what is the width of the column? So this is 400 and the depth of the column is 600. What dimensions for the footing we have provided? The dimension for the footing is this is 3800 mm and this is 4050 mm. These are the dimensions. These are the dimensions we have provided for the footing. Now critical section is at a distance of d by 2. So how much this total distance becomes? This distance, how much it is? So it will become 400 plus d. It will become 400 plus d. Similarly, if you think about this distance, how much it is? The distance किती असणार आहे एवढं? This will be 600 plus d. This will be 600 plus d, where d is the effective depth. So now we will calculate the shear force first. Okay, we will calculate the shear force first. So the shear force notation for this is Vu. We have studied this already in detail, which is equal to what? Stress oblique pressure. Stress into area, na? Into area. Basic formula for force. So that it can be calculated as Vu is equal to stress means soil pressure. How much is the pressure? 204.67. That is 204.67 stress into area. Now after punching, when the column penetrates to the footing, and this is the rectangle through which it penetrates. Okay. So the remaining area will be this much area. This is the remaining area outside. So now here, how much that area? From inside outside area you can minus this inside area. So what is the area now? The area will be 3800 into 4050 minus here it is 400 plus d into 600 plus d, and this bracket is complete. Now do the calculation and let me know the equation. VU is equal to, पहिल्यांदा आतले ब्रॅकेट तरी सॉल्व करा सगळे. 204.67 into here it is in bracket, this multiplication, how much it is? 3800 into 4050, it is 15.39 into 10 to the power 6, this minus, now this is the minus sign. Now do this calculation. 400 by 600 multiplied by 400. So how much it is? 600 into 400. So it is 240 into 10 raised to 3. 240 into 10 raised to 3. Again, this is minus because outside my bracket is minus. Then this is d into 400. So d into 400 means what? D into 400 means minus 400d. Then again this 600 into this plus d. Okay. This 400 into d, it will also become minus. Then याला multiply केलं परत ह्याने 600d. So you also solve simultaneously with me and check whether any term is get misplaced or any calculation is goes wrong. Let me know immediately. This is unsolved problem. This is also not solved with me. So please do check the calculations. Calculation part please check. Minus value आली परत काय येणार आहे? Minus 600d minus 400d and minus d square. This is the bracket. Okay. So if you open the bracket, your sign will be like this. So now multiply each and every term with this 204.67. So VU is equal to, this will become say minus 600 minus 400 is minus 1000. So how much it is now? 204.67 into first quantity is 15.39 E6, 149 into 10 to the power 9 minus here it is 240 10 to the power 3. So it is 49.120 into 10 raised to 6. Again minus 600 minus 400 minus 1000. So minus it is 1000. So it is 204.67 into 10 raised to 3. 67 into 10 raised to 3 d. And last one is minus 204.67 d square. So again if you simplify this, your VU is equal to how much it is? If you see these two quantities, then it is 3.149 into 10 raised to 9 minus 49.120 10 raised to 6. So this term will be 3.09 into 10 raised to 9. These two terms will be as it is, minus 204.67 7 into 10 raised to 3 d minus 204.67 d square. Okay, so this is your equation number 1. Please check the values. If any value is wrong, then let me know at that time. After calculation of the shear force, now we calculate the shear resisted by concrete. The next thing is shear resisted by concrete. So now you know that how to calculate the shear resisted by the concrete. Now how to calculate that? Roll number 37. Mute yourself. Mute the mic. So shear resisted by the concrete. So it can be calculated as VUC, that is shear resisted by the concrete, it is tau CBD. It is tau CBD. So first of all, we will calculate this value of tau C. So the permissible shear stress tau C is equal to, the formula for this is 0.25 under root FCK. So it is 0.25 under root 20, which is equal to 1.118 Newton per mm square. This is nothing but in kilonewton per meter square. 118 kilonewton per meter square. So it is 118 kilonewton per meter square. This is the value of tau c. So now, what is the shear resisted? So to calculate the shear resisted, we should consider that diagram which we have drawn in the first problem. See this. This is the area along which you will calculate the shear resistance, because this area is going to punch, and while punching the shear resisted will be along the depth of the footing, along the depth of the footing. So now what will be the area? So if I draw the separate diagram for this, I will draw over here. Now if you see over here, this dimension is nothing but overall depth of the footing. Here will be the depth, effective depth up to the reinforcement, small d we have considered over here for the area. Okay. So now d is the depth. So what is the dimension now? See how much is the dimension? Along x direction, now along x direction dimension is 400 plus d. Along y direction the dimension is 600 plus d. Okay, so here along x direction, suppose now I will consider this as 400 plus d. This I will consider as 600 plus d. So instead of showing there, we will show over here this dimension, it is 600 plus d. And here this dimension, this is 400 plus d. This is 400 plus d. So how much area will be there which we will contribute here? This is area number 1, this is second area, this is third area, this is fourth area. So now if this effective depth is d, if this depth is d, what is the first area? I will write single area one by one so that you can understand. So A1 first area. What is the first area? It is 400 plus d. Okay, this is 400 plus d. One dimension is 400 plus d. Multiply by this depth. So multiply by this d. This is your first area. Multiply by d. Okay, this is your first area. A1. Now what is A2? What is A2? Now if you see A2 is this much of area, this rectangle. Okay. So this is 600 plus D, and this is the D. So that area will be 600 plus D into D. Similarly, you can write here A3 and A4. Whatever may be the area of A1, that may be all area of A3. And whatever is the area of A2, the same area will be for A4. So here I can multiply A1 by 2, multiply A2 by 2, so that we will get all the areas. I hope now this is understood. And if I want to calculate the total area A, then it will be 400 plus D into 2D. This is single area plus again 600. What will be the total area? So A will be, it is 400 plus D into D. This is our first area. So we have multiplied this area by 2, so that A1 and A3 get covered. And then similarly the second area is 600 plus D into D. Okay, this is A2 and A4, so multiplied by 2. This is our total area from which you will get the shear resistance, shear resisted. So I will write over here all the things collectively. So shear resisted by concrete VUC is equal to tau C 1118 into BD, means this area. So this area is, here I will write 2 into bracket 400 plus D into D, this bracket complete, plus again 2 into, here in bracket 600 plus D into D, this bracket will complete and this total bracket will complete. So this is the area now. Now you need to simplify each and every term. So VUC is equal to, I will keep this 1118 as it is, into, now do the multiplication inside the bracket by 2D. 2D is direct आप multiply करा. So it will be 400 into 2, 800, 800D. Here it is 800D. Plus if I multiply inside with 2D, it is 2D square. It is 2D square. This is for first area. Plus for second area it is 1200D plus how much it is again? 2D square. 2D square. Now everything is in plus. So we can write VUC is equal to 1118 into, here 800 plus 1200, it is 2000, 2000D plus 2 plus 2 4, it is 4D square. Now multiply inside with this 1118. Now if you multiply inside, all of you are hearing me? What we are doing over here, what is going on? See, here we made a small mistake and it will cost us a very big mistake. So who will tell you what we have done exactly? अशी आपल्याकडनं एक साधी मिस्टेक झाली की आपण हे 118 किलो न्यूटन पर मीटर स्क्वेअर मध्ये घेतलेले युनिट आणि इथे घेताना 400 आणि 600 हे mm मध्ये घेतलेले युनिट्स आहेत. ओके, so we have not maintained the unit uniformity. That is why we are getting the answer in 10 raised to 6 and 10 raised to 3 format. Okay, I think in the previous equation number 1 also we have not maintained the unit properly. Okay, that is why this problem is there. I think so, because 400 and 600 are the units, these are the units in mm, and here triple one eight is the intensity we have taken in kilonewton per meter square. Okay, so per meter square here we are taking, and here we are taking the dimensions in mm. So that is why we need to rectify this. Okay. So I will write the equations once again. First I will write this equation, and then we will see the previous equation. So VUC is equal to, what is happening? So 1118 into, what is our area now? It is 2 into 400 plus D is 0.4 plus D, and multiply this by D. This is the first area, plus second area is 2 into 0.6 plus D into D. So VUC is equal to 1118 into, in bracket, here it is 0.8 D plus 2D square plus 1.2 D plus 2D square. So VUC is equal to 1118 into, in bracket, 0.8 plus 1.2, again it is 2, 2D plus 2D square. So now finally VUC is equal to, it is 1118 into 2. So how much it is? 2236 plus, again it is 1118 into 2. So it is again 2236 d square. D into D, it is d square. 2236 d square. This is your equation number 2. Okay. Same mistake we have done in equation number 1 also. So that we are getting the values in 10 raised to 3, 10 raised to 9. So just scratch that. We will write once again the equation number 1 also. So in the equation number 1, VU is equal to, what was the stress intensity? VU is equal to 204.67. This is the stress into area. Again, while taking the area, this is in kilonewton per meter square. So your area will be 3.8 into 4.05. This is the total area, minus, from that area you need to minus this punched out area. So what is the punched out area now? How much it is? 0.4 plus D and 0.6 plus D. Okay, so it is 0.4 plus D into 0.6 plus D. This is your punched out area. So now we need to solve this. So VU is equal to, how much it is? 204.67 into, here in the bracket, how much is this value? It is 15.4. This is 15.4 minus, now solve this bracket. So I will keep the bracket as it is. And now I will keep the bracket as it is first. So it is multiplied by 0.6 into 0.4. 0.4 into 0.6. So it is 0.24. 0.24. Then 0.6 into this, then plus 0.6 d. Then multiply by d plus 0.4 d. Then again multiply by d plus d square. Okay. Now outside this bracket negative sign is there. So VU is equal to 204.67 into, here it is 15.4 minus, now this will become First 0.6D plus 0.4D, it is only D. Okay, if you add these two. So this will become minus 0.24 minus D and minus D square. Minus D square. So we use equal to, it is 20.4.67 into here in the bracket. It is 15.4 minus 0.24. So answer is 15.16 minus D minus D square. So now again multiply these terms by 204.67. So what is the answer? 204.67 multiplied by 15.16. So it is 3102.79 minus 204.67D minus 204.67D square. This is your equation number 1. ओके, मगाशी आपलं काय झालं होतं, लक्षात आलं का तुमच्या? असं एक्झाम मध्ये होऊ शकते. वी हॅव टेकन दिस क्वांटिटी इन किलो न्यूटन पर मीटर स्क्वेअर स्ट्रेस and we have taken all these dimensions in mm. 400, 600, those are in mm. Actually we should take the same unit. आणि आपण काय झालं, हे mm मध्ये घेतलं आणि हे मीटर मध्ये घेतलं, त्याच्यामुळे त्या मोठ्या क्वांटिटीज येत होत्या सगळ्या 10⁻⁹, 10⁶. ओके, सो डू द करेक्शन. So in this way, now you can see that how the maintaining the uniformity of units is so much important. Okay. Now equate these two equations. Equate these two equations to calculate the value of depth. Okay. So to calculate the value of depth, here you can say equating VU, that is shear force to the shear resisted by concrete, that is equation 1 and equation 2. So I will write here both the equations. So first equation is 3102.79. 3102.79 minus 204.67D minus 204.67D square. Okay, this is our first equation. Second equation is 2236D, 2236D square. So this is equal to 2236D plus 2236D square. So now take the terms which are d square च्या टर्म एकत्र घ्या, d च्या टर्म एकत्र घ्या, काय मिळेल तुम्हाला? So 2236 minus, now this minus will become plus if you send it to that side, so plus 204.67, so it will become 2440.6 d square. Okay. Plus here it is 2236 and again plus 204.67. This will also become 2440.6 d, and this plus term will become minus when you send to that side, which is equal to 0. Now solve this equation, so you will get the value of d. D is equal to 0.73 meter, or D is equal to minus 1.73 meter. Okay. So depth is never negative. So therefore our effective depth D is equal to how much? It is 0.73 meter, which is equal to 730 mm. Please check the answer. So your depth of the footing is 730 mm. Depth of the footing is 730 mm. So this is your effective depth. This is your effective depth. Now calculate the overall depth. Assume 16 mm bar diameter and 50 mm clear cover. So here I will write, assume clear cover of 50 mm, and we will go for 20 mm diameter bars. 20 mm bar diameter. Okay. You can go for 16 also. So your overall depth D is equal to 730 plus clear cover is 15, 50, okay, plus half of bar diameter, 20 by 2. So what is the answer? How much it is? So it is 730 plus 50 plus 10, 790. So your 790 mm. So this is your overall depth. This is your overall depth. So we have adopted effective depth as 730 mm, and then our overall depth is 790 mm. Okay, this is from what? This is from two-way shear criteria. Okay, if we find out this overall depth later on, then also it is okay, no problem. Okay, if we found out this overall depth later on, then also it is no problem. So just I have found out here. Later on also, if it is required, we will find out, or we will take this same value. It doesn't matter. Okay. So this is from what? One-way shear criteria, two-way shear criteria. So I think we will take this step later on. हे जे आपण कॅल्क्युलेट केलेलं आहे ना, ते पुढे कॅल्क्युलेट करू किंवा ह्याला इथं असंच ठेवलं तुम्ही तरी चालेल. देयर इज नो wrong in this. Okay, there is no wrong in this because the two-way shear depth is always comes out to be higher. So now this is from the two-way shear 0.73. Similarly, we will calculate the depth from one-way shear criteria. Now second, depth from one-way shear, depth from one-way shear criteria or consideration. Depth from one-way shear consideration. Okay. So for that now, again, what we will do? First, we will see right here the critical section. Critical section is at distance capital D, sorry, small d, that is effective depth, from face of column. From face of column. Now I will draw the diagram for that. So suppose now this is our column. This dimension is 0.4, 400 by 600. No, this is 0.4, this is 0.6, 0.4 and 0.6. Now the critical, I will draw the footing. Now on either side, we will take critical section at a distance d. So here is the critical section. which is at a distance d. So this dimension, this is d. And in a similar fashion, we will take another critical section. Now this critical section is parallel to y. Another which is parallel to x we will consider over here. This is the critical section which is parallel to x. And here the measurements. We can write this as d. So now we are having two strips. Also we know that how much is this length. We know that how much is this total length and this length. So how much it is? This is how much in x direction. It is 3.8 meter. So it is 3800 mm. So instead of that we will take in meter because we have taken point 4 point 6. So it is 3.8 meter and this is 4.05 meter. 4.05 meter. Now let me know what is this remaining distance. How much is this one and how much is this one. These distance we need to find out now. हे distances आपल्याला find out करायचे. Okay. So how to calculate those distances now? So this is the centroid. This is the centroid. Now see, from this center, if this total distance is 0.4 for the column, if this total is 0.4, then from this center it is 0.2. Okay, and if this total is 3.8, then from this center up to this point, this will be half. So half of 3.8 is 1.9. So from the 1.9, if you minus this 0.2, you will get the distance from this end, from the face of column to this end. Okay, so I will mark over here. I am talking about this distance, this total distance, and how much it is. If you want to calculate this distance, then it is 3.8 by 2 minus 0.4 by 2. Okay, 0.4 by 2. So how much it is? 1.9 minus 0.2. It is 1.7. Okay, so this is 1.7. 1.7 meter. So what is this remaining then? Then this distance will be, if this is 1.7 and this is d. Okay, if this distance is 1.7 and this is d, then this remaining will be width of the strip. This remaining distance will be how much? It is 1.7 minus d. 1.7 minus d. Okay, so I will call this as strip number 1 and I will call this as strip number 2. So area of strip number 1. Area of strip number 1, I will call that area as A1. How much that it is? It is 4.05 into 1.7 minus d. हे पहिल्या याचा एरिया झाला फर्स्ट स्ट्रिप. आय विल राईट हिअर स्ट्रिप 1. ज्या स्ट्रिपचा एरिया मॅक्सिमम असेल ती स्ट्रिप आपण घेणार आहोत फॉर फर्दर कॅल्क्युलेशन. Now just focus on this strip number 2. Okay. Now for the strip number 2, here this is zero point 0.6. For strip number 2, this is 0.6 and this total is 4.05. So from the center, here is the center. From center to this end, the distance will be 4.05 by 2. We will get this distance. And from this total distance from the center, we can minus this 0.3 as this total is 0.6. we can minus 0.3, so we will get this total distance. And from that total distance, when you minus this d, you will get this strip. So what is the distance now? It is 4.05 divided by, it is 4.05 divided by 2 minus 0.6 by 2. So it is 1.725. Now if you see this total distance from this point up to here, we have calculated this total distance as 1.725. So 1.73. So this will be 1.73 minus b. So I can write now for strip 2, what is the area A2? So A2 will become for strip 2 this नंतर या लेक्चर नंतर. This is 3. हाँ सोडायचं आहे का मग? ठीक आहे सोडतोय एकच मिनिटात. So A2 is equal to, it is 3.8 into, it is 1.73 minus b. Now you can see that which area is greater, that we need to consider. Okay, स्ट्रिप 1 चा एरिया जास्त आहे का 2 चा एरिया जास्त आहे हे आपल्याला बघावं लागणार आहे. आणि त्याच्यानुसार मग पुढच्या कॅल्क्युलेशनला, शिअरच्या कॅल्क्युलेशनला 1 नंबरची स्ट्रिप घ्यायची का 2 नंबरची हे ठरवायचं आहे. पण हे एरिया ठरवताना व्हॉट इज द प्रॉब्लेम नाउ? वी डोंट नो द व्हॅल्यू ऑफ डी. डी इज अननोन फॉर अस. Okay, so we don't know A1 is greater or A2 is greater. So in these types of situation, what we do, we will take some arbitrary value of D. Okay, D ची एक व्हॅल्यू आपण अज्युम करतो इथल्या इथे एरियाची व्हॅल्यू काढायला. समजा मी असं अज्युम केलं की जे D आहे ते D आहे 100 mm. अज्युम करा फक्त 100 mm म्हणजे किती झालं 0.1 मीटर. अशी जर मी D ची व्हॅल्यू अज्युम केली तर A1 आणि A2 ची व्हॅल्यू काढा किती येईल. What will be the value of A1 and what will be the value of A2 now? So to calculate the value of A1, what will be the value? 1.7 minus 0.1. So it is 1.6 into 4.05. So what will be the value of A1? It is 6.48 meter square. And same for A2, if I put the same value, then it is 1.73 minus 0.1 into 3.8. How much it is? 6.19 meter square. So who is greater? A1 is greater or A2 is greater? A1 is greater. So this area is greater. Now if A1 is greater, then which strip we should consider? Strip number 1. So this strip we should consider for further calculation. Strip number 1. Okay. So here you can write that. Here you can write. We can consider. We will consider. We will consider strip 1, okay, of area. What is the area of strip 1? 4.05 by 1.7 minus d. This is the area. Okay, so further calculations we will see in the next lecture. Okay, now on your group CC will send you one link. You have to join that program. Okay, it is started at 2:45 only. Already we are late, so join that program. And right now you send your roll number in the chat box. Okay, and you can leave the lecture and see the instructions which